Last time, we left off saying that atoms are the smallest indivisible unit of matter. This seemed to be the correct description of the universe for some time. However, less than a century later, we start running into some problems. What happened was that scientists were playing with electricity, and in doing so they heated up some metals to a high enough temperature with a negative voltage on them, such that those metals started making the air around them glow. When they took away the air, i.e. put these hot metals in vacuum tubes, they saw the walls of the vacuum tube would glow. This suggested that some particles were emitted from the negatively charged hot wire that would light up the first thing it hits. Let's look at a setup like this in detail. This is a schematic of a tube with no air inside it, and one side hooked up to a large negative voltage. It looks like this in real life. When you turn on the electricity, the walls start to glow. What can we learn already? We see a perfect shadow of the cross right here. This means that whatever is causing the walls to glow that is coming from the hot wire must be traveling in a straight line for us to get this shadow. Now, what happens if we put a magnet near the wire? In the second picture, we see the glow has moved up. From this, we can deduce that whatever is causing the glow is bent up in this magnetic field. Any guesses to what will happen if we flip the direction of the magnet? The beam now turns down. See the green glow here? If you know a little bit about the laws of electricity and magnetism, which the people of that day did, you can figure out that what was emitted was negatively charged. At this point, we, and the scientists of the 19th century, still didn't know if what we are seeing are particles, like the atoms from before, or if they are immaterial rays, like light. A scientist called J.J. Thomson cleverly figured out not only how to measure the charge of these mysterious emissions, but also how to measure their mass. In the next lecture, I'm going to walk you through the basic physics behind how he did his measurement. I will show you how, using two perpendicular electric and magnetic fields, he was able to deduce the beam's exact velocity. With that knowledge, and seeing how far the beam was deflected in a subsequent electric field, he was able to find the charge-to-mass ratio of what the beam was made of. What he found shocked the scientific world and earned him a Nobel Prize in the process.